So today we're going to talk about parent graphs. Basically, for parent graphs, they give you like a template um, for functions, so you have an idea of what to expect. So I like to start with like y equals x squared, y equals x cubed, right? So it give you an idea of what a function is going to look like before you actually have to sit down and graph it out by hand. By the way, a really good tool for graphing, anytime you want to graph something, is Desmos.com. And to get to the graphing tool, it's desmos.com/calculate. So put that in, type in any function you want, and once you put that equation, it'll pop up on a graph for you. It's very useful, way more useful, way faster, and easier than your actual TI graphic calculator. Okay, so really simple. Let me just pick a color here. Y equals X. So when you do Y equals X, just so you know, I'm trying to build your intuition for these things. Y equals X. Why didn't it come out blue? 1 second. Should have came out blue. Let's try this again. Y equals X is just going to be a straight line that splits your X and Y um, coordinates exactly in half. So it's going to look like here's your Y coordinate. Here's your X coordinate. And then here's y equals x. All right, so that's this one in blue. Okay, for red, let's do y equals x squared. So that's just going to be a U shape like that. Okay, that's y equals x squared. That's the parent graph. That's where you start off. And the reason you want to know parent graphs is because once you know parent graphs, you can use translations and transformations to look at more complicated versions, right? Where you either multiply by something, add or subtract something, uh, all of that kind of stuff. You start off with the parent graphs, and then you learn how the transformations and translations change that parent graph. So that was y equals x squared. And then for y equals x cubed, actually, let me come over here. We need to add one just to give you guys an idea. Well, yeah, no, that's good enough. Let's do y. Let's take a green. Y equals x cubed right here. And what that looks is like kind of like a sideways Z. So let me see if I can get this right. Let's do this. It's going to have a curve here. Goes like this. And it comes down like that. Oh, that's ugly. Hold on a second. Does this. Comes over like that. Comes down. Okay. So that's y equals x cubed. It's like a sideways Z. Now the reason I usually start by teaching these three curves, well actually that line and then y equals x is the line, so then these two are curves, is because from here you can kind of get a sense of any other uh, kind of exponential function, right? Because what happens is as you go from y equals x squared to y equals x fourth to the fourth power, and actually any even number, x to the sixth, x to the eighth, right? I probably should have done this video in Desmos now that I think about it, so you can see the graphs live. Maybe I'll do that later. But all of these look kind of like this red one, right? This red U-shaped curve. The only difference is as you increase this power to higher and higher even numbers, 8, 10, 12, whatever, um, this curve starts to square off. So it gets less round like a U, and it starts to do this, right? Let's just assume you get to a very high even number. It's going to do that, right? It's going to become a square. Same for y equals x to the third power. As you go to x to the fifth and any other positive odd power, x to the seventh, x to the ninth, whatever, it's still going to have the same overall shape, but it won't be smooth anymore. So let me use another color like purple. It's going to start to box off. So that's what's happening. It's losing its smoothness as you get higher and higher in um, odd odd power. So I hope that helped give you kind of a start on what your parent graphs look like, at least for these functions. There's other functions too, but you can always, maybe I'll plot those in Desmos later. Um, Here's what they look like. 1 second. I keep trying to use keyboard shortcuts. So you know you got the radical of x. Let's see here. So what's that one? Radical of x. You have the natural log of x. Let me make these. You have what other functions can I think of? You have the absolute value of x. You have a few other special functions, right? You could have e raised to the x, the exponential function. Um, so those kinds of things. Oh, also you have your trigs, right? Your sine of x, cosine of x, your trig functions, tangent of x. Um, but yeah, you don't have to actually wait for my video. You can always pop these into Desmos, and you can see for yourself. But I'll probably follow up with. I might follow up with a video on how these functions look. They're paragraphs, but essentially these are the main ones you're going to be using. These top three. These are kind of like special, and because I'm only really covering the essentials in this course, um, I probably won't get to these with a like their own standalone thing. But maybe if you guys request it. Okay. Thanks. Hope that helps. If you have any questions, leave it in the comments. All right. Thanks.